Hey everybody, I hope you're having a fantastic day. I have a mailbag, and the main reason why I'm doing this mailbag is because I actually need the stuff that's in there, so let's get to it. The first one was a freebie that I signed up for I don't know how long ago, and it is this stuff here. Oh, interesting. It is this stuff called Advanced Bed Adhesive Engineering Polymers. And so it is a coating to nanomer polymer adhesive. It is a fancy coating that you put on the bed of your 3D printer by a company called visionminer.com. They had a giveaway a while ago and I ordered it. And yeah, I just want to give it a shot. So I have no idea if it does anything worth doing. I don't really struggle a lot with build plate adhesion. But I thought, what the heck, we'll give it a shot and see if I can re-stick my bed if it ever gets unstuck. And next we have this one that actually did get opened. But it is, let's see here, let's grab this out. It is this goofy thing that I found for $2.50 on AliExpress. And when this showed up, I really had no idea why I bought it, but it's essentially a measuring device. I think it can be used also as a centering device to draw centered holes on things. I'll have to do some instructions, but I did get a 2x4 here. Let's see if it's really obvious. So this is in millimeters. So I don't know. I got a pencil here. You know, seems like you could use it for something like that and draw, you know, lines up the middle of something if you had a way to figure out what the middle was. A little compass looking thingy here, 45. Yeah, I mean, I don't know. It was cheap. Let's see what we got here. We have these holes for this is 4/0, 10/0. I'm guessing those are millimeter sizes. I don't know, 3.5 millimeter, 10 millimeter. This is, oh yeah, this is like a protractor here. We've got angles from 0 to 90. We've got this little compass protractor looking thing. We've got this little slidey thingy here. I don't know, $2.50, was it worth it? Probably not. Okay, this one, I know what this is because I ordered it. And I have a very specific project in mind with this, and I'm guessing that by the end of the video, you'll know what that project is. But I'm going to crack this open. And you've seen a lot of arcade buttons on my channel, but you've never seen one of these. And this is an arcade joystick. Now, I used to build a lot of main machines and big arcade machines back in the day, and you saw I did a little bit of repair on one. And in fact, I got that thing and I kicked it down the road pretty quickly. But this is an arcade joystick, and I'm a little, okay, yeah, it has a pin on here. So once I put this in, I'm gonna have to pull the pin to get it out. But the way this thing works is it has the same, it's kind of weird they only used one screw on each one, but I guess it's up against a fixed pivot point. But this uses 4 of the same microcontrollers that are, or micro switches that are in all those HAP arcade buttons. And what's kind of funny about it, you have to, when you're working on one of these things, so I'm just going to put this in, I think I can get it to trigger. When I push this to the left, I'm actually hitting the right micro switch. So I push this and this pivots out to the left. So when you're designing controls for these things and you're using this thing, you always have to reverse everything. So left from the top is going to be the right switch, and then, you know, up is down, down is up, and these are just these are always normally open. There's not, these micro switches are so cheap they don't even have the normally closed pin option on there. But this was like $11 from Amazon, and I bought this because I needed it relatively quickly for a project. And so to be honest, I bought this and then I was originally going to use it, and then I had less of a need for this thing because of the last item you'll see in the video. And but it gave me a new opportunity to build something else, so I have another use for this. So I'm opening it up. That didn't make a whole lot of sense, I'm sure, but you'll get it by the end of the video. And the last item on the desk is this. Now, I've actually never owned this style of this thing here. It is well packed. And I paid Amazon prices for this, so I paid 20 bucks or so, maybe 15 bucks for this thing. But this is an 8-channel solid state relay board. And for comparison, I've got one attached to a Pi here. This is an 8-channel mechanical relay board with some tape stuck to it. And so, focus. Okay. This board has some advantages over this board. Now these are cheap. I buy these for $3 all the time. And there's a mechanical relay. I'm going to do an entire Raid My Lab on relay, so I'm not going to spend a lot of time talking about them. But this is an opto-isolated, which if you've watched Simple Electronics video, he cut one of these opto-isolators apart. And so this is electrically isolated, and there's like a little mechanical reed in here that flips back and forth when this little relay is either energized or de-energized, and that allows you to control a bigger load, like an AC load, like a lamp or something like that, with a Raspberry Pi or an Arduino, and it's relatively low voltage. Now, this works on similar principles, except the opto-isolator is basically built inside of this relay, and it has, instead of flipping a mechanical switch, it uses like a triac or a transistor, a MOSFET or something like that. And the advantage of this one is that because there's no moving parts, there's no magnetism going on or anything like that to flip things around, you can switch this load dramatically faster and dramatically more reliable than these. In fact, I've actually broken some of these by trying to flip them on and off too fast. And I have a need for some nearly instant reaction times on my relays. And so I bought this 8-channel solid state relay board. Now the one downside to something like this is that it cannot control as big of loads. And I don't know off the top of my head, oh, it's written right here. Yeah, so these can only do 2 amps, where this can do, I think, 10. Yeah, this one can do 10 amps at 250 volts or 15 amps at 125. So you are not going to control anything nearly as big with this solid state relay as you will with the mechanical relay, but you make up for that in speed. So downsides are cost and the amount of load you can control. The upsides are the speed and the reliability. So I'm going to put this thing to a test in a project and see how that goes. And I've got to leave the desk to show you the next one. Okay, so the next one's a little bit hard to fit on my desk, but here we go. It's a claw machine. I needed to simulate a claw machine, and I thought, you know what? Why don't I just get a claw machine? And so it actually works. Oh, we're never getting that. Oh, we're never getting that. Oh, I'm terrible at these things. I'm not going to get into a ton of reasons of why I bought this thing and what I'm going to do with it. Those will all come with future videos. But I thought I would show you the claw machine, and I'm going to do a video showing you how the thing works and how to adjust it and maybe some other cool modifications we can do to it. So, hey, thanks for watching. Have a great day.